Welcome to the Explainer, where we break down complex topics into clear, engaging explainers.
You know, there's this invisible force that powers pretty much everything you do online. And today, we're going to pull back the curtain on it. We're talking about virtualization. And believe me, it is the engine that makes the whole modern internet go. So here's what we've got on the agenda for today's Explainer.
All right, let's dive right in. Now, you might hear the word virtualization and think, okay, that's some high-tech data center stuff, right? And you're not wrong. But what if I told you it's actually a huge part of your everyday life? I mean, think about this for a second. How can one single physical computer pretend to be a dozen different computers all at the same time? It really does sound like a magic trick, doesn't it? But this is the key. It's what unlocks the secret to how the internet can be so massive and so flexible. And the answer to that magic trick? It's virtualization. I'm telling you, you use it every single day. You fire up Office Online? Yep, that's a virtual machine. You connect to a VPN for work? That's a virtual network. Even when you mount an ISO file to install some software, that's a kind of virtualization too. See? It's everywhere. Okay, so we've established it's everywhere. But what is it really? What is this invisible force? Let's unpack the core idea. Okay, here's the simplest way to think about it. Virtualization is the tech that lets us take one really powerful physical computer and slice it up into a bunch of smaller, independent, virtual computers. We call them VMs, or virtual machines. And here's the kicker. Each one of those VMs thinks it's a completely separate, real computer.
Now, you have to understand why this was such a game changer. It solved a huge, expensive problem. See, back in the day, you had one server for one application. That was it. But here's the thing, most of the time that super powerful server was just sitting there, barely doing any work, maybe using 10% of its power. It was a crazy waste of hardware, of electricity, of physical space in the data center. So the really critical thing to get here is that from the inside, each virtual machine has no idea it's sharing. It thinks it has its own private hardware. It's a totally separate system, even though it's running on the same physical box as a bunch of others. It's just a really clever and efficient illusion.
Okay, so how do you pull off a trick like that, right? How do you actually fool a whole operating system into thinking it has an entire computer all to itself? Well, you need a secret weapon, a sort of master controller, and that's where something called the hypervisor comes in. This master controller, it's not hardware. It's a special layer of software called the hypervisor. Sometimes people call it a virtual machine monitor, or VMM for short. But honestly, thinking of it as the digital puppet master for the whole show, that's a pretty perfect description.
And the way it works is actually pretty elegant. Look, you start at the bottom with the real physical hardware, the actual servers. Then you lay this hypervisor software right on top of it. It's the layer that talks to the metal. And then the hypervisor is the one that creates and manages all those separate virtual machines running on top.
So with this setup, the hypervisor basically has two main jobs, and they're both absolutely crucial. Job number one, hide the real hardware from the virtual machines. Make each one think it has total control. And job number two, which is just as important, build strong walls between those VMs. Isolate them from each other so they have no idea the others even exist.
And when the hypervisor does those two jobs perfectly, it unlocks three incredible benefits. We can basically think of them as virtualization superpowers.
Okay, so what are they? They are isolation, encapsulation, and interposition. Kind of technical sounding names, I know, but these three concepts, building on each other, are literally why virtualization changed everything. Let's break down what they actually mean.
First up, isolation. Remember those walls between the VMs? Well, that means if one of them crashes or, gets a virus, the others are completely safe. They just keep on running, totally unaffected. It's a fantastic safety feature. Plus, it lets you do cool stuff, like run a Windows server and a Linux server right next to each other on the very same physical machine. Okay, now we get to encapsulation, and this part is just brilliant. The hypervisor takes that entire virtual machine, the operating system, the apps, the data, everything, and packages it all up into a single file. It's like building a ship in a bottle, but for a computer. And since the whole thing is just a file, you can move it, copy it, back it up. It's incredibly portable. And that leads us to the third superpower, Interposition. See, because that computer in a file is totally isolated, it can't talk to the real hardware directly. It has to ask the hypervisor for everything: CPU time, memory, network access. This means the hypervisor sits right in the middle, like a gatekeeper. It sees and can control every single thing that happens. From a security and management standpoint, that is a massive, massive advantage.
So isolation, encapsulation, interposition, these aren't just abstract ideas. These superpowers are used every single day to solve very real problems in data centers all over the world. They're the reason the websites and apps you use stay up and running.
So let's talk about some of those real-world problems. For instance, what happens if a physical server just dies? Or on the flip side, what if an app on one of your servers suddenly goes viral and gets 1 million new users? Well, virtualization has some pretty amazing answers for both.
This is where it all comes together. If a server is about to fail, you use something called VM motion. Remember that computer in a file, thanks to encapsulation? You can literally move that entire running computer over to a different, healthy physical server without ever turning it off. Zero downtime. It's incredible. And for that viral app, that's where dynamic resource scheduling, or DRS, comes in. It's smart software that sees one VM is working really hard and automatically gives it more horsepower, more CPU, more RAM from the shared pool to handle the load.
And just to be clear, we're not talking about some niche, exotic technology here. This stuff is the industry standard. I mean, just look at the adoption rates. The vast majority of companies are using these tools. It's how they keep everything we rely on running smoothly, 24/7. So, what happens when you take all of this? The hypervisor managing everything, the superpowers of isolation and encapsulation, these smart tools like VM motion and DRS? What do you get? Well, you get the foundation for the entire modern internet. You get the cloud.
That's right, the cloud is built on virtualization. Think of it like a stack. At the very bottom, you've got the physical hardware in giant data centers. On top of that, you have the virtualization layer, the hypervisor, creating this huge pool of resources. That pool is what companies like Amazon and Google sell as infrastructure as a service. And on top of that is where all the platforms and the apps that you and I use every day live. Virtualization is the engine that makes the whole thing work.
So it's pretty clear that virtualization completely changed the game for computing. It took rigid physical hardware and created this incredibly flexible, powerful virtual world on top of it. It really makes you wonder, right? We've virtualized computers, storage, networks. What's next? What other parts of our real physical world could be transformed by this same idea?